Hello everyone. Today's topic is construction and working of nicol prism. So we will just discuss about the nicol prism. What is nicol prism? How do we construct the nicol prism? And how does it act? Okay, nicol prism ante enti. So first of all, it is a optical device made from the calcite crystal. So it's just like optical device which is made from the calcite crystal. Calcite crystal chemical name is calcium carbonate. Okay. It is used in many optical instruments for producing and analyzing the plane polarized. నికోల్ ప్రిజమ్ ని ఎక్కడ యూజ్ చేస్తారంటే కొన్ని ఆప్టికల్ ఇన్స్ట్రుమెంట్స్ లో యూజ్ చేస్తారు. ఎందుకు యూజ్ చేస్తారంటే టు ప్రొడ్యూస్ ద పోలరైజ్డ్ లైట్. ఏదైనా అన్పోలరైజ్డ్ లైట్ ఉందనుకోండి, దాన్ని మనం పోలరైజ్డ్ లైట్ ని కన్వర్ట్ చేయాలంటే ఇఫ్ యూ పాస్ ఇట్ త్రూ ద నికోల్ ప్రిజమ్ యూ విల్ గెట్ ఏ పోలరైజ్డ్ లైట్. అండ్ ఆల్సో ఒక్కొక్కసారి ఏదైనా ఇన్స్ట్రుమెంట్ నుంచి పోలరైజ్డ్ లైట్ వచ్చింది అనుకోండి, వెదర్ ఇట్ ఈస్ పోలరైజ్డ్ లైటా కాదా అన్నది వెరిఫై చేయడానికి అనలైజింగ్ ద ప్లేన్ పోలరైజ్డ్ లైట్ ఆల్సో we will use the nicol prism. Okay, so nicol prism ని పోలరైజ్డ్ లైట్ ప్రొడ్యూస్ చేయడానికి యూజ్ చేస్తారు అండ్ ఆల్సో అనలైజ్ ది పోలరైజ్డ్ లైట్. The name comes from William Nicol, who invented this device. That's why the name is nicol prism. And nicol prism completely works based on the principle of phenomenon of double refraction. Double refraction phenomena dwara it will work. Okay, double refraction means any unpolarized light incident on doubly refracting crystal, it will split into the two rays. ఒకటి O ray కింద డివైడ్ అవుతుంది, ఇంకోటి E ray కింద డివైడ్ అవుతుంది. సో సేమ్ థింగ్ I have written here. When unpolarized light passes through a calcite crystal, it splits into two refracted rays, O ray and E ray. And O ray యొక్క vibrations ఎలా ఉంటాయి? Perpendicular to the plane of the vibration, whereas E ray యొక్క vibrations will be parallel to the plane of the vibration. Okay, both are plane polarized lights and both are perpendicular to each other. Okay, but I want to get only one polarized light. But calcite crystal lonchi light refract light padinappudu it will divide it into two refracted beams. These two refracted beams are plane polarized beams, but I want to get only one polarized light. So how do I get? So we have to eliminate one of them. Either you eliminate E ray or either you eliminate O ray, so that you will get only one polarized beam. So nicol prism em chestadante, it is made in such a way that it eliminates O ray. అంటే నికోల్ ప్రిజం నుంచి లైట్ పాస్ చేసినప్పుడు టూ రేస్ కింద డివైడ్ అవుతుంది, ఈ రే అండ్ ఓ రే కింద. బట్ నికోల్ ప్రిజం ఏం చేస్తుంది అంటే ఓ రేని కంప్లీట్గా ఎలిమినేట్ చేసి మనకి బయటకు వచ్చే లైట్ రే ఏమవుతుంది, ఈ రే. ఓకే, అండ్ ఈ ఓ రే ఎలా ఎలిమినేట్ అవుతుంది అంటే ఇట్స్ బై టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్. టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్. సో ఐ విల్ జస్ట్ ఎక్స్ప్లెయిన్ యూ టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్, TIR, simply shortcut. Okay, so rarer medium, denser medium. Okay, I'm just writing D. D means denser medium. When light goes from denser to rarer medium, first condition, light must go from denser to rarer. If light comes from rarer to denser, you will not get any total internal reflection. So first priority, light should go from denser to rarer medium. Okay, if the angle of incidence, okay, greater than the critical angle, so angle of incidence greater than the critical angle, అంటే క్రిటికల్ యాంగిల్ కంటే ఎక్కువ యాంగిల్ తో ఇన్సిడెంట్ అయినప్పుడు దిస్ లైట్ రే ఇన్స్టెడ్ ఆఫ్ గోయింగ్ టు అదర్ మీడియం, అంటే ఆ సెకండ్ మీడియంలోకి వెళ్ళకుండా ఇట్ విల్ కంప్లీట్లీ రిఫ్లెక్టెడ్ బ్యాక్ ఇన్ టు ద సేమ్ మీడియం. ఇట్స్ యాక్చువల్లీ ట్రాన్స్పరెంట్ మీడియం అమ్మా. సో what we expect usually, a transparent medium మీద లైట్ పడినప్పుడు it should go to another medium. సో బట్ ఏంటంటే ఎప్పుడైనా సరే ఏదైనా లైట్ రే డెన్సర్ మీడియం నుంచి రేరర్ మీడియంకి వెళ్ళినప్పుడు ఆ లైట్ రే కనుక ఇఫ్ ద క్రిటికల్ యాంగిల్ కంటే ఎక్కువ యాంగిల్తో ఇన్సిడెంట్ అయితే ఇట్ విల్ నాట్ గో టు అదర్ మీడియం, ఇట్ విల్ కంప్లీట్లీ గో ఇన్ టు ద సేమ్ మీడియం. ఇఫ్ సపోజ్ థీటా ఈజ్ లెస్ దాన్ క్రిటికల్ యాంగిల్ కంటే తక్కువ యాంగిల్తో ఇన్సిడెంట్, దట్ రే విల్ గో అదర్ medium instead of going to the semi. Okay, so total and internal reflection means light rays should go from denser to rarer medium, and angle of incidence must be greater than the critical. These 2 points must meet to get a total internal reflection. Okay, so ఈ నికోల్ ప్రిజం లో టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ ద్వారా ఓరేని ఎలిమినేట్ చేస్తాము. ఓకే, and we will get only E ray outside, so it is a plane polarized beam. This is how we get a polarized beam through the nicol prism. Now we will discuss about the construction of the nicol. How do we construct nicol prism ni ela tayar chestam? Okay, so as I said, the nicol prism is nothing but a calcite crystal. Okay, so let me use this marker. Okay, nicol prism is just like a calcite crystal. Calcite will be in the shape of rhombohedron. Rhombohedron means it's like a 3D diagram. Okay, you know parallelogram. This is parallelogram. Okay, if it if it has 6 faces, one face, second face, and third. Okay, similarly fourth. So all this is something like rhombohedron, which will be in the parallelogram in 2D diagram. Okay, so you take a calcite crystal which is in rhombohedron shape. Okay, and the length must be 3 times the thickness of the crystal. If you take the thickness of the crystal, the length of the crystal must be 3 times of the, this is the first condition. Okay, length must be 3 times of the thickness. So here I am just showing this diagram. ABCD represents initially you are taking rhombohedron shape of the calcite crystal whose angles are something like 71 degrees and 109. So if you add both of them, you will get 180. Okay, so 71 plus 109 degrees. Initially, whatever you have taken a calcite whose length is 3 times of the thickness and the angles are something like this. Okay, now what you will do is this this crystal, you just make it a cut or polish on both sides like A, B, okay, and CD. Na? So you cut the surface of AB. Okay, so I will draw once again. So this is ABCD, here it is there. You cut such a way that AB, so initially this is ABCD, right? Now you cut such that this I'm just drawing here. Okay, and you cut such or you polish it this crystal such that it should make angles like 68. Okay, 68 and 112. See here clearly shown here. Initially A, B, C, D. AB here it is AB it is here written as dotted lines. So initial crystal was shown in the dotted. Okay, so I am just to show you once again. This is whatever we have taken initial crystal. So D, C. Okay, so A, B, C, D. Okay, now I cut them into the along the edges of the ABCD. Okay, so so this will be new crystal. Okay, and this will be C dash. Okay, so this is my new crystal after cutting the initial crystal. A dash B, C dash D is my new crystal, and whose angles will be 68 and this will be 110. Again, if you add both of them, you will get 180. Okay, so initially ఏదైతే క్రిస్టల్ ఉందో దాంట్లో 71 degrees 109 degrees ఉన్నాయి. దాన్ని ఏం చేసాం, ఆ ఎడ్జెస్ లో కట్ చేయగా we will get a new type of new crystal with angles will be different 68 112. Okay, so ఈ వచ్చిన క్రిస్టల్ ని you cut along the diagonal means A dash and C dash, you cut A dash along A dash C dash, so that it will be divided into the two prisms. It looks like something like this. Okay, when you cut along the diagonal, you will get a two prisms. Okay, if you add them, okay, if you join together these two crystals, how do you join them? There will be a special transparent material which is something like act as a glue. That glue is called as Canada balsam. Okay, so Canada balsam అనే ఒక ట్రాన్స్పరెంట్ గ్లూ ఉంటుంది. ఆ గ్లూ ద్వారా you can add those two pieces. Okay, so Canada balsam, it's a transparent glue material to add those two pieces. Okay, so Canada balsam యొక్క refractive index of Canada balsam CB, okay, it will be 1.55. okay, and refractive index of ordinary ray is 1.658. These three are very important values you should know, you should remember. Refractive index of extraordinary light ray is 1.486. These three values you should remember. Okay, so Canada balsam యొక్క refractive index 1.55, refractive index of ordinary ray 1.658, refractive index of extraordinary ray 1.486, and the lower portion of BC is coated with lamp black, which will absorb the light rays. Okay, so I will just explain you next working of the nicol prism. How does it eliminate O ray, and how you will get only E ray from the nicol prism. Okay, nicol prism pani enti, you will get only E ray outside of the nicol prism, and O ray will be absorbed by crystal using the total internal reflection phenomena. Okay, so I will explain you how does it work, how we will get E ray outside the nicol prism. Okay, when an unpolarized light is allowed to enter nicol prism, okay, it suffers a double refraction as shown in figure. If you see here, initially I have written here, so A dash B C dash D is our new nicol prism, and in between there is a Canada balsam layer. I will draw diagram here, so I will draw at the end. Okay, so that you will so you take nicol prism, so which is parallelogram shape. Okay, this is, let's say this is nicol prism. Let unpolarized light is incident on the nicol prism, and nicol prism at the diagonal you will have a Canada balsam layer which is used to join the two pieces, right? So this is called Canada balsam layer. This is, okay, mu CB, and this is calcite portion, this is calcite portion. So when light falls on the doubly refracting crystal, what happens? I said double refraction takes place. Double refraction means you will get O ray and extraordinary ray. Okay, so let's say there will be two light rays. This is E ray and this is O ray. Okay, and E ray యొక్క vibrations ఎలా ఉంటాయి? It will be parallel. So so it will be, so it's so not good. O ray vibrations are dotted vibrations. Dot means perpendicular to the vibration. So I will go to the up initial one. So diagrams are very clear there. So you see here in this diagram, A dash B C dash D is a nicol prism in which there is a Canada balsam layer. Okay, so this is a Canada balsam layer. So when light ray incident on the nicol prism, this is unpolarized light incident on it, it will divide it into the two light rays. This is one light ray, this is another light. This light ray is nothing but E ray. Okay, and this light ray is nothing but O ray. Okay, so O ray యొక్క vibrations ఎలా ఉన్నాయి? They are perpendicular to the plane of vibration. That's why it is represented by dot. Whereas E ray యొక్క vibrations ఎలా ఉన్నాయి, they are parallel to the plane of the vibration. That's why they are represented by arrows. Okay, so when this O ray incident on the Canada balsam, okay, so Canada balsam layer యొక్క refractive index, just now I told you it is 1.55. okay, whereas O ray యొక్క refractive index 1.658. okay, so which of the refractive index value is more? So O ray యొక్క refractive index is more as compared to the Canada balsam layer. okay, Canada balsam layer యొక్క 1.55, O ray యొక్క refractive index 1.5 1.658. so which will be a denser medium then, which has more refractive index, that will act as a denser medium. So for O ray, this calcite crystal act as a denser medium, okay, because its refractive index is high, and Canada balsam layer will act as a rarer medium, which because it has less refractive index as compared to the O ray. okay, so I told you when light ray goes from denser to rarer, what kind of phenomena will takes place? Total internal reflection takes place if and only if the angle of incidence greater than the critical angle. ఇక్కడ ఇది ఇన్సిడెంట్ అయింది కదా, so if the angle of incidence is greater than the critical angle, then the light ray will not go into the other medium, it will go into the same medium. okay, that's why it is reflected into the same medium, and this reflected ray will be absorbed by this BC layer. BC is coated with black lamp black, okay, that will absorb the O ray lights. okay, if you see the E ray, E ray is getting incident on the Canada balsam. ఇక్కడ E ray యొక్క refractive index I told you 1.458 something. okay, so it has a less refractive index, so this calcite crystal will act as a rarer medium for E ray. For E ray, the calcite crystal, it will act as a rarer medium. Rarer medium nunchi, so Canada balsam layer will act as a denser medium. Rarer medium nunchi light to denser medium padinappudu, it will just pass into the another medium. It will just pass into the medium and come out of the nicol prism. okay, so E vibrations will come out of the nicol prism, and O ray will be absorbed by the crystal because of the total internal reflection. ఈ టోటల్ ఇంటర్నల్ రిఫ్లెక్షన్ అవ్వడానికి మెయిన్ కారణం కెనడా బాల్సమ్ లేయర్ రిఫ్రాక్టివ్ ఇండెక్స్ ఓరే యొక్క రిఫ్రాక్టివ్ ఇండెక్స్ కంపేర్ చేస్తే ఓరే యొక్క రిఫ్రాక్టివ్ ఇండెక్స్ ఎక్కువ కాబట్టి కాల్సైట్ క్రిస్టల్ ఓరేకి డెన్సర్ మీడియం కింద యాక్ట్ చేసి, సో లైట్ డెన్సర్ మీడియం నుంచి రేరర్ మీడియంకి వెళ్ళినప్పుడు యాంగిల్ ఆఫ్ ఇన్సిడెన్స్ కనుక క్రిటికల్ యాంగిల్ కంటే ఎక్కువ ఉంటే, that light ray will not go into the another medium, it will just simply totally reflected into the same medium. okay, so this is what how does it is the working of the nicol prism. Same thing I explained here. See, refractive index of the ordinary light is greater than the refractive index of the Canada balsam layer, so that it will work as a denser medium. O ray, calcite crystal will act as a denser medium for O ray, whereas CB, Canada balsam layer, act as a rarer medium. okay, so that's why total internal reflection takes place. And ఇక్కడ critical angle find out చేశాను నేను, which is using the sin inverse mu c by mu o. We know refractive index of CB, we know refractive index of ordinary ray. So using that, if the critical angle will be something 69 degrees, అంటే ఓరే గనక 69 degrees కంటే ఎక్కువ యాంగిల్ తో ఇన్సిడెంట్ అయినప్పుడు total internal takes place. okay, if O ray incident greater than 69, the O ray undergo total internal reflection and O ray completely absorbed by the BC surface. okay, so E ray simply enters to the other medium and you will get a transmitter. So by this we came to know that nicol prism నుంచి మనకు వచ్చే లైట్ కంప్లీట్లీ ప్లేన్ పోలరైజ్డ్, అండ్ బయటకు వచ్చే లైట్ రే కూడా ఎక్స్ట్రాడినరీ లైట్ రే whose vibrations are parallel to the plane of the paper or plane of the vibration. okay, so this is very important point, I will highlight this one. So nicol prism eliminates O ray and provides only E ray which is polarized. అంటే నికోల్ ప్రిజం యూజ్ చేస్తే మనకు వచ్చే లైట్ పోలరైజ్డ్ లైట్. ఓకే, అది ఏ టైప్ ఆఫ్ పోలరైజ్డ్ లైట్? E ray. ఓకే, so this is what the production of the polarized light using the nicol prism, and we will later see how does the nicol prism will be utilized in the analyzing. Okay, analyzing means మనకు వచ్చిన లైట్ పోలరైజ్డ్ అయితే అది నిజంగా పోలరైజ్డ్ లైటా కాదా అన్నది అనలైజ్ చేయడం అనమాట. ఆ అనలైజేషన్ కూడా we can do it with nicol prism. So in next coming classes we will discuss later. Okay, so by this time you should remember that nicol prism నుంచి ఏదైనా లైట్ పాస్ చేస్తే మనకి బయటకు వచ్చే లైట్ కంప్లీట్లీ పోలరైజ్డ్ లైట్, అది కూడా ఈ రే అవుతుంది. ఓకే, నౌ నెక్స్ట్ టాపిక్ ఈజ్ Malus law. Okay, so you might have studied in intermediate. Just definition I will read out here. It states that when a beam of plane polarized light, you see some of the I will underline the some points here, you should remember very carefully. It states that when beam of plane polarized light, అంటే ఏదైనా plane polarized light from a polarizer is incident on analyzer. See ఇక్కడ two types of in this diagram if you see, so there are two polarides. Okay, so this is one polaroid, this is another polaroid. First polaroid will be treated as polarizer. Any polaroid which is placed after the polarizers are called analyzers. Okay, so second one is analyzer. In this statement you see plane polarized light from a polarizer is incident on analyzer. అంటే ఏదైతే లైట్ ఈ పోలరైడ్ నుంచి వచ్చిందో, ఫస్ట్ పోలరైజర్ నుంచి వచ్చిందో దాన్ని ప్లేన్ పోలరైజర్ అంటారు. చూడండి ఇక్కడ అన్పోలరైజ్డ్ లైట్ పాసెస్ త్రూ ద పోలరైజర్, అంటే నికోల్ ప్రిజం గుండా వెళ్తే nicol prism is acting as a polarizer, you will get a completely polarized light. So this is polarized light. Okay, so Malus law states that this polarizer నుంచి ఏదైతే ఈ పోలరైజర్ నుంచి ఏదైతే లైట్ వచ్చిందో దట్ ఈస్ కాల్డ్ ప్లేన్ పోలరైజ్డ్ లైట్. అది కనుక ఇన్సిడెంట్ అయితే దేని మీద? అనలైజర్ ఈజ్ నథింగ్ బట్ ది సెకండ్ పోలరైజర్. ఓకే, సో అనలైజర్ మీద ఇన్సిడెంట్ అయితే ద ఇంటెన్సిటీ కమింగ్ అవుట్ ఆఫ్ దిస్ అనలైజర్ is proportional to the square of the cosine of the cos square theta. Okay, square of the cosine angle between the plane of the transmission of the polarizer and analyzer. ఈ రెండాట్లకి ఇది ఒక ట్రాన్స్మిషన్ యాక్సిస్, ఇది ట్రాన్స్మిషన్ యాక్సిస్. ఓకే, సో లైట్ పోలరైజర్ నుంచి వచ్చిన లైట్ విల్ బి కంప్లీట్లీ పోలరైజ్డ్ లైట్. ఆ పోలరైజ్డ్ లైట్ కనుక అనలైజర్ మీద ఇన్సిడెంట్ అయినప్పుడు ఈ రెండాట్లు ట్రాన్స్మిషన్ యాక్సిస్ ఉన్నాయి కదా, ఆ యాంగిల్ సమ్ యాంగిల్ మేడ్ ఉండుంటుంది. ఆ యాంగిల్ కి సో ఇంటెన్సిటీ కమింగ్ అవుట్ ఆఫ్ ది అనలైజర్ విల్ బి ప్రపోర్షనల్ టు ది కాస్ స్క్వేర్ ఆఫ్ ది కాస్ థీటా. ఓకే, అంటే రెండు ట్రాన్స్మిషన్ యాక్సిస్ ఏ యాంగిల్ తో ఉన్నాయో అన్నది ఇంపార్టెంట్. ఓకే, సో ఐ విల్ జస్ట్ ఎక్స్ప్లెయిన్ యూ వన్స్ అగైన్. సో దెర్ ఈస్ అన్పోలరైజ్డ్ లైట్ హియర్ విచ్ ఈస్ ఫాలింగ్ ఆన్ ఏ పోలరైజర్. పోలరైజర్ పని ఏంటి? అన్పోలరైజ్డ్ లైట్ ని పోలరైజర్ కింద పోలరైజింగ్ అదే ప్లేన్ పోలరైజ్డ్ లైట్ కింద కన్వర్ట్ చేస్తుంది. సో ఇంటెన్సిటీ ఏమవుతుంది అంటే ఇనిషియల్ I0 ఉంటే ఇట్ విల్ కమ్ యాజ్ I0/2, అంటే హాఫ్ ఆఫ్ ది ఇంటెన్సిటీ విల్ బి అబ్జార్బ్డ్ బై ది polarizer so that only half intensity will get. If you place another analyzer which is same axis, you will get the same intensity of the light. Okay, suppose instead of keeping parallel to the polarizer, analyzer ni parallel kanda unchukunda, if I kept it at particular angle, you see in below diagram shows you that initially unpolarized light will be converted into the polarizing beam. Okay, so if this second polaroid placed at a particular angle, so ఇక్కడ ట్రాన్స్మిషన్ యాక్సిస్ సమ్ యాంగిల్ థీటాతో ఉంది దీంతో కంపేర్ చేస్తే. ఓకే, So it is at a particular angle. So there is another Polaroid which is at an angle theta t. Okay, so here I am drawing. Okay, so this is at this transmission axis is at an angle theta. Okay, sorry, with this axis, angle between the this transmission axis and this transmission axis is theta. Okay, so here this transmission axis is like this, and there is analyzer which is at an angle theta t. Okay, what happens to this intensity? Intensity, as I said, according to Malus law, intensity is proportional to the square of the cos squared. We will prove it. Okay, so to prove that, what I am just considering is this parallel light whose amplitude is something a. Okay, so this is along the transmission axis. Let's say this transmission axis I am drawing here, and another transmission axis which is at an angle theta, and this plane polarized light is parallel to this one. So let's say amplitude of the plane polarized light is along this transmission axis A. Since it is making an angle theta with another transmission axis, we can divide this amplitude into two times. Okay, two components. So horizontal component and vertical component. Horizontal component will be a cos theta. Vertical component will be a sin theta. Okay, and we know that only those light ray which are parallel to the transmission axis will be come out of the polaroid. So ikkada deeniki ee transmission axis ki a sin theta అనేది perpendicular component, whereas a cos theta అనేది parallel component. So ఈ transmission axis కి which light will be parallel? A cos theta is the parallel. సో ఏదైతే parallel గా ఉంటుందో ఆ లైటే బయటకు వస్తుంది, whereas perpendicular గా ఉండే light will not travel along the polaroid. So transmission axis కి parallel గా ఉన్న light మాత్రమే బయటకు వస్తుంది. That you should remember. సో ఇక్కడ మనకి transmission axis కి a cos theta only parallel, so you will get only the a cos theta term. So you will get a cos theta out of the this polarizer. Okay, analyzer we call it as. So intensity is the square of the a cos theta. Okay, which is nothing but a square cos square theta. Okay, so this I will denote here. So initially you are getting from initial polarizer a square, which is proportional to the a square. So second analyzer nunchi vachina light to I dash is equal to k into a square cos square theta. Okay, so if you divide it, you will get finally the light coming from the analyzer. Okay, so I will write down here. So light coming from the second polarizer. Okay, edaithe second undo, second polarizer, initially one polarizer is there. Okay, p, we call it as p analyzer. So light coming from the analyzer I dash is the final intensity. I is the light which is coming from the polarizer. Okay, ఈ polarizer నుంచి ఏదైతే లైట్ వచ్చిందో దాన్ని I అంటాం. Okay, so intensity of the analyzer, intensity coming out of the analyzer is proportional to the intensity into the cos square theta. Okay, so you just remember that Malus law is I dash is equal to I cos square theta. That is called Malus law. Yeah, then we should know. So we just now discussed Malus law and nicol prism. Malus law is nothing but I is equal to I naught cos square theta. I naught is the intensity of the light coming from the polarizer. I dash is the intensity coming out from the analyzer. Okay, we also we will discuss now. There are three types of polarizers. Okay, what is polarization of light wave describes the shape and locus of the tip of the E vector at a given point in space as a function of time. Did you get anything from this statement? So I will explain you. So electric vector E which will have a tip. Okay, so this tip and locus and shape. Locus means position, and shape. The electric field vector travels in the space. Okay, it will move in the space. So when it moves, this tip vector, it makes some shape. Okay, sometimes it will make a circle, sometimes it may make ellipse, sometimes it may go linearly polarized beam. So depending upon the shape and locus of the tip of the vector at a given point in space, we will get a three different types of states of polarization. Okay, those are all called plane polarized beam, so circularly polarized beam, and elliptically polarized beam. I will explain you what are those things. Okay, so plane, depending upon the tip of the E vector, we will get a three kinds of polarized beams. Plane polarized light. What is plane polarized light? The magnitude of the light vector means E vector. If the magnitude of the light vector, okay, so light vector will have some magnitude, let's say E bar. Okay, magnitude of the light vector changes, but its orientation remains. So let's say this is oriented like this. When it moves in the space, if the orientation remains same and the amplitude reduces, sometimes it can be less, it can be very less. Okay, so if the magnitude decreases or changes with the time, okay, but the direction always remains unchanged, then such kind of polarized light beams are plane polarized light. Okay, plane polarized light law, amplitude will be varies in time in space. Okay, but the direction of the electric field vector remains same. Such kind of light vectors are called plane polarized light. In circular polarized light, what happens? So if you see, the magnitude of the light vector remains constant, but its orientation remains at a constant, rotates at a constant rate. So this is just opposite to the plane polarized light. Plane polarized light లో ఏం చెప్పాను, magnitude చేంజ్ అవుతుంది, డైరెక్షన్ కాన్స్టెంట్ గా ఉంటుంది. ఈసారి సర్క్యులర్ పోలరైజ్డ్ లైట్ లో ఏమవుతుందంటే మ్యాగ్నిట్యూడ్ కాన్స్టెంట్ గా ఉంటుంది. ఓకే, ఐ విల్ డ్రా హియర్. సో this time magnitude remains constant. Okay, and direction will change. So rotation of the direction will change. So such type of polarized beam is called circularly polarized beam. Okay, next one, circularly polarized light ni ఒక్కొక్కసారి we can treat as it is just a result of the superposition of two mutually perpendicular plane polarized lights having equal magnitude but a phase difference. అంటే circularly polarized light రావాలి అంటే sometimes ఏం చేస్తారంటే, if you take two plane polarized lights, okay, which were plane polarized lights which are having equal amplitude, if the phase difference between them is, this is one plane polarized light and this is another plane polarized light, both are having the same amplitude, and the phase difference between them is 90 degrees. If they combined superposition of these two plane polarized lights, you will get a circularly polarized light. Okay, so this is how one can get the circularly polarized light. So okay, next thing is, if the rotation of the tip vector is seen clockwise direction. Suppose this rotation of the circularly polarized vector is in the clockwise direction, then it is called right circularly polarized light. If the rotation is anti-clockwise direction, okay, left side, then it is called left circularly polarized light. Okay, similarly we will discuss about the elliptically polarized light. Till now, plane polarized light law, magnitude changes, direction remains constant. Circularly polarized, just opposite. Magnitude remains constant and direction changes. Now is that elliptical what you expect? Both will change. ఇందాక దాంట్లో ఏదో ఒకటి చేంజ్ అయ్యింది, ఈసారి రెండు చేంజ్ అయితే యూ విల్ గెట్ elliptically polarized. So that means if magnitude of the light vector as well as its orientation changes about the direction of the problem, so you will get a elliptically polarized light. Okay, so elliptically polarized light లో magnitude direction రెండు చేంజ్ అవుతాయి. రెండు చేంజ్ అవడం వల్ల you will get a elliptically polarized light. Okay, so this is all about the plane polarized light and circularly polarized light and elliptically polarized light. Now I will just discuss about there are some retardation plates, okay, which are nothing but quarter wave plate and half wave plate. Okay, what is meant by retardation plate? Retardation plate is generally a plane parallel plate of అంటే ఏదైనా బైరిఫ్రెజెంట్ క్రిస్టల్ ఉందనుకోండి, లైక్ క్వార్ట్జ్ కానీ మైకా కానీ, with the optic axis in the plane of the surface. It is oriented so that incident polarized light may be resolved into the components projected along the optic axis and perpendicular to it. These two components will experience a relative phase shift proportional to the thickness of it. Ikkada important point is, I will just explain you. See, ikkada ee point very important. See, by retardation plate ante em ledamma, you take some birefringent crystal, doubly refracting crystal. This is a doubly refracting crystal. Ee doubly refracting crystal మీద light incident అయితే ఏమవుతుంది, it will divide into two components, and E ray and O ray. Okay, అది ఆప్టిక్ యాక్సిస్ గుండా ఒక యాంగిల్లో ఇన్సిడెంట్ అయితే you will be resolved into the two components. Okay, సో ఈ టూ కాంపోనెంట్స్ ఏమవుతాయంటే దే విల్ ఎక్స్పీరియన్స్ అంటే సపోజ్ లెట్స్ సే ఈ రే ఈజ్ హ్యావింగ్ సమ్ యాంగిల్ థీటా విత్ ఆప్టిక్ యాక్సిస్. ఓకే, ఆప్టిక్ యాక్సిస్ తో ఈ రే ఉన్నప్పుడు యూ కెన్ డివైడ్ ఇట్ ఇంటూ టూ కాంపోనెంట్స్. వన్ ఈజ్ అలాంగ్ హారిజంటల్ కాంపోనెంట్, అనదర్ ఈజ్ అలాంగ్ వెర్టికల్ కాంపోనెంట్. ఓకే, ఈ టూ కాంపోనెంట్స్ కి there will be some phase difference. This phase difference will be introduced, will be proportional to the thickness of the plate మీద డిపెండ్ అయి ఉంటుంది. ఓకే, సో retardation plates లో any plane polarized light will be divided into the two components. Our two components will have a phase difference proportional to the thickness of the plate. That is called retarding plates. When the fractional part of this retardation is non-zero value, the wave plate modifies. So అప్పుడు ఏమవుతుందంటే ఈ వేవ్ ప్లేట్ ఏం చేస్తుందంటే, ఇనిషియల్లీ there is some plane polarized light is coming, that will be converted into the circularly polarized or circularly polarized, elliptically polarized. Okay, you suppose if there is a circularly polarized light is incident on the doubly refracting crystal, so that will be modified into the either plane polarized light. Okay, so retardation plates ఏం చేస్తాయంటే they will not produce any polarizing beam, but what they do is they change the polarization state of the light. Okay, అంటే మనకి ఇన్సిడెంట్ లైట్ కనుక ప్లేన్ పోలరైజ్డ్ లైట్ ఇన్సిడెంట్ అయిందనుకో, you will get a circularly polarized light, or sometimes you may get elliptically polarized. So ఒక పోలరైజేషన్ స్టేట్ నుంచి ఇంకో పోలరైజేషన్ స్టేట్ కి కన్వర్ట్ చేస్తుంది రిటార్డేషన్ ప్లేట్. ఓకే, ఇట్ విల్ నాట్ ప్రొడ్యూస్ ఎనీ పోలరైజింగ్ బీమ్. It will not produce any polarizing beam. So that point is highlighted here. A wave plate does not polarize light. అంటే మనకి పోలరైజేషన్ లైట్ ప్రొడ్యూస్ చేయదు, బట్ ఏం చేస్తుంది అంటే ఇన్స్టెడ్ ఇట్ విల్ చేంజ్ ద స్టేట్ ఆఫ్ ది ఇన్కమింగ్ పోలరైజ్డ్ బీమ్. ఏదైతే పోలరైజ్డ్ బీమ్ ఇన్సిడెంట్ అవుతుందో దాని యొక్క పోలరైజేషన్ స్టేట్ ని మార్చేసి వేరే పోలరైజ్డ్ బీమ్ కింద కన్వర్ట్ చేస్తుంది. ఓకే, so there are two types of waves, quarter wave plate and half wave plate. The name itself implies quarter means lambda by 1/4, right? So quarter means 1/4. So let's say lambda by 4th, 1/4. Quarter means 1/4. Wave means wavelength. Okay, lambda by 4 plate. అంటే ఈ ప్లేట్ ని గనక మనం ఇంట్రడ్యూస్ చేస్తే there will be a path difference between the two components of the plane polarized beam. నేను చెప్పాను కదా ఇందాక డబ్లీ రిఫ్రాక్టింగ్ క్రిస్టల్ ఉంది, లైట్ టు ప్లేన్ పాలరైజ్డ్ లైట్ ఇన్సిడెంట్ అయింది, ఈ లైట్ సమ్ యాంగిల్ తో ఇన్సిడెంట్ అవుతుంది, కలిసి అదే ఆప్టిక్ యాక్సిస్ తో సమ్ యాంగిల్ తో. ఇట్ విల్ బి డివైడెడ్ ఇంటూ టూ కాంపోనెంట్స్. ఈ టూ కాంపోనెంట్స్ మధ్య పాత్ డిఫరెన్స్ ఎంత ఉంటుంది అంటే λ/4 ఇఫ్ దిస్ ఇఫ్ దిస్ ప్లేట్ ఈజ్ ఎ క్వార్టర్ వేవ్ ప్లేట్. ఓకే, ఈ క్వార్టర్ వేవ్ ప్లేట్ ఉంచడం వల్ల you will get a λ/4 path difference between the two components. Okay, path difference λ/4 అయితే phase difference ఎంత అవుతుంది? It will be pi/2. Okay, so path difference λ/4 or phase difference pi/2 will be between the two rays, O ray and E ray మధ్య ఇంత అంటే క్వార్టర్ వేవ్ ప్లేట్ కనుక whose thickness is such that it produces a path difference λ/4 or phase difference pi/2 between O ray and E ray. Okay, so let's say the thickness of the crystal is T. దీని యొక్క క్రిస్టల్ యొక్క థిక్నెస్ T అనుకుంటే, and we know the refractive indexes of the O ray and E ray are mu naught and mu e. Okay, then phase difference ఏమవుతుంది అప్పుడు, path difference ఏమవుతుంది? path difference ఫార్ములా delta is nothing but path difference. Okay, and there are two rays, refractive index of O ray into thickness is called path difference of the path traveled by O ray minus path traveled by E ray. Path traveled by E ray is nothing but mu into T. Okay, can I take it as T as common? So you will get mu naught minus mu e. So since quarter wave plate we are using, so path difference we know λ/4. Okay, so λ/4 equal to mu naught minus mu e. Then thickness of the plate ఎంత అవుతుంది అప్పుడు? T is equal to λ/4 times mu naught minus mu e. Okay, so they will ask mostly problems on this kind of on this formula only. So they will ask mostly what will be the thickness of the plate such that the plate introduces a λ/4 path difference. They will give you the values of mu naught, mu e, lambda. You have to find thickness of the calcite crystal. Okay, so this you remember, for the thickness of the quarter wave plate can be find by using this formula. So here sometimes they will ask negative crystal. They will say simply negative crystal. They will not give you any so you should remember that in negative crystal mu naught is greater than mu e. Okay, so this formula is valid as it is. If it is positive crystal, if they mention, we know that positive crystal refractive index value is smaller than the refractive index of extraordinary. So then the formula will be T is equal to λ/4. What happens? Mu e minus mu o. Okay, refractive index minus refractive index of ordinary light ray. Okay, so because positive crystal law refractive index value of extraordinary ray is greater than the refractive index of the ordinary ray. Okay, so next thing is quarter wave plate is used to produce circularly polarized light and elliptically polarized light from a plane polarized light. Okay, what this point says is, so you use a quarter wave plate and light is incidenting on this plate. Okay, this is a plane polarized light. PP, I am just writing PP means plane polarized light. The light coming out of the quarter wave plate, either it can be circularly polarized light CP or elliptically polarized light EP. Okay, so plane polarized light ni circularly polarized light can convert చేయాలన్నా or electrically polarized light can convert చేయాలన్నా you have to use quarter wave plate. This is very important point. Okay, you should remember quarter wave plate ఏం చేస్తుంది, మనకు వచ్చే ప్లేన్ పోలరైజ్డ్ లైట్ ని సర్క్యులర్లీ పోలరైజ్డ్ లైట్ కింద కన్వర్ట్ చేయాలన్నా ఆర్ ఎలిప్టికల్లీ పోలరైజ్డ్ లైట్ కింద కన్వర్ట్ చేయాలన్నా we will use quarter wave plate. Quarter wave plate యొక్క path difference ఎంత? λ/4. Okay, sometimes they will call as λ/4 plate also. ఓకే, క్వార్టర్ వేవ్ ప్లేట్ ని లాంబ్డా బై 4 ప్లేట్ అని కూడా అంటారు. Now off wave plate, off wave means off 1 by 2, wave means wavelength, so lambda by 2 plate also we call it as. So this is similar way. Thickness of the plate and ఎలా ఉండాలి అంటే it must introduce a path difference lambda by 2 or phase difference pi between O ray and E ray. అంటే ఏదైనా క్రిస్టల్ మీద లైట్ పడినప్పుడు దాని యొక్క క్రిస్టల్ యొక్క థిక్నెస్ ఎలా ఉండాలి అంటే ఇట్ మస్ట్ ఇంట్రడ్యూస్ పాత్ డిఫరెన్స్ లాంబ్డా బై 2 ఆర్ ఫేజ్ డిఫరెన్స్ పై బిట్వీన్ ఓరే అండ్ ఈరే మధ్య అంత పాత్ డిఫరెన్స్ ఇంట్రడ్యూస్ చేస్తే ఆ ప్లేట్ ని మనము ఆఫ్ వేవ్ ప్లేట్ అని అంటాం. ఓకే, సో సిమిలర్లీ టు ఫైండ్ అవుట్ ద థిక్నెస్ we will use this formula. T is equal to lambda by 2 mu naught minus mu e. Similarly, they will ask what happens for a negative crystal, what happens for positive crystal. So you should find out the refractive indexes of the positive and negative crystals. Okay, so these are all about the retarding plates. Quarter wave plate ఏం చేస్తుంది, plain polarized light ని circularly polarized light కింద కన్వర్ట్ చేస్తుంది, లేదా elliptically polarized light. Next class we will discuss about the theory of the production of the polarized light and mathematical expressions, how you are getting circularly polarized light, how you are getting elliptically polarized light, and also experimentally we will also discuss how we will get both circular and elliptically polarized light. Okay, and also last section is analysis, whether the light is unpolarized light or polarized light or circularly polarized or elliptically polarized. So we will discuss in next class. Okay, thank you everyone.